NeurIPS took place last week in San Diego, along with a satellite event in Mexico City. And as you may know, that's the largest AI conference in the world. More than 15,000 attendees every year. And this year, more than 21,000 papers were submitted, although only somewhat more than 5,000 of those were accepted by the editorial committee for publication. Still, that's a lot of papers to read through. Of those, only 6 won prizes. And of those, 3 of the winners could have a direct impact on the AI world right away, while the other 3 covered topics that were more theoretical. So, for this video, let's look at those top 3 papers that have the potential to have a direct impact on the way that AI is done today. Number 1, this paper. This one explores the impact of a deep network as applied to reinforcement learning. As context, most recent studies related to this area have used around 2 to 5 layers. But this paper explores what happens when up to 1,024 layers are used for this. By the way, the reason that other researchers only used a handful of layers until now is not because they didn't think about trying more. It's because they felt there's no reason to add more. They felt there wasn't enough information generated by a reinforcement learning task to justify the scale of a deep neural network, which is a logical idea on the face of it. But this paper introduces a novel and fairly easy to implement paradigm for the training of very deep neural networks on this kind of task. And as a result, the authors achieved a 2 to 50x improvement in performance on reinforcement learning tasks. So, that changes the whole game. So, you can see why this paper won a top award. Based on this, we can probably expect that reinforcement learning tasks will start to scale more like LLMs in the near future and going forward. Number 2, this paper. This one describes a simple architectural change to the design of language models that consistently improved model training and scalability and performance on about 30 experiments, including experiments involving deep models and transformer models that used trillions of tokens. So, as you might guess, the work that's described in this paper could only have been done by a team like this one that had access to industrial scale computing resources. The technique they describe involves gating, which is like adding a dimmer switch that decides how strongly certain information should influence the model's output. Specifically, the authors used a sigmoid gate, which produces a number between 0 and 1. So instead of letting every signal pass through at full strength, the model learns to emphasize some signals, adjust others downward, and maybe turn some signals off completely. And this is done after the model has already computed its attention weights. Basically, after each attention head finishes its work, the model adds a small adjustment that determines how much of that head's output should be used. And this small tweak improves model performance because it gives the model a safety valve to stop any one head from having too much influence. Specifically, it's the first token that's the main culprit here. That token consistently gets disproportionately high attention scores across multiple layers, which means that the model places too much emphasis on information from the first token as you can see represented here. What we want is a more balanced treatment of tokens, like you can see here. By the way, this undue emphasis on the first token was already a well-known problem that's been widely discussed. So, finding a simple, elegant solution for this is a very good thing. In fact, this new gating mechanism is already being used now by the Qwen 3 Next model. And the authors have been very generous to share their code with us as open source. So, as a result, there's already a wide consensus that this design enhancement will quickly be adopted by the rest of us in future versions of other top models as well. And number 3, this paper. The main insight of this one is that LLMs now exhibit a strong tendency to converge on the same ideas, even when a vast array of different creative solutions could be imagined. And the authors use the evocative term hive mind to describe this tendency. Notably, this thesis got tested and quantified on a dataset consisting of 26,000 diverse open-ended user prompts. Here's an example to illustrate. We ask a llama model to write a metaphor involving time. It writes, "Time is a river that flows relentlessly, carrying memories and experiences along its currents, shaping the shores of our lives with every passing moment, and ultimately emptying into the vast ocean of eternity." All right then. We then ask a Qwen model to create a metaphor that relates to time. It writes, "Time is like a river that flows constantly, carrying us along its current." We then ask a Gemma model to write a metaphor involving time. It writes, "Time is a river relentlessly flowing, carrying us all downstream." You get the idea. This was supposed to be a request to come up with something creative and original, but instead, we consistently get a sort of cliché response across models. And also from the same model, even when we keep asking the same thing over and over again, worded in slightly different ways. What's notable about this paper is that it's actually the first time that researchers have ever systematically studied the behavior of language models when presented with open-ended requests of this type, where there's no ground truth answer. And in reviewing the findings, we're suddenly reminded of the tension between our goals related to conformity, reduce the risk of inappropriate content, for example, versus originality and diversity in AI systems, which is an interesting problem, especially in regard to use cases where creativity would be quite valuable, like in marketing, for example. So, there you have it, 3 of the top highlights from NeurIPS this year. Of course, that leaves out 5,287 papers that I didn't talk about. So if you attended a great poster session or featured talk, let me know about that in the comments. Meanwhile, thanks for watching and see you next time.